Hi, I'd like to welcome everybody to the Bablake Design and Technology Department. My name's Chris West, I'm Head of Department. And I'd just like to run through and talk to you about the A-level syllabus, what we do for the upper six and the lower six and how it works. So on the next slide is basically the assessment. So the assessment is based on a piece of coursework, which is 50% of the total marks. 50% also on 2 written papers. So the 2 written papers are split. One is a 2-hour paper, one is an hour and a half. And it covers all the basics. So if you're doing GCSE design technology now and you're doing wood, metal, plastics, resistant materials, then that's what we build on in the exams in the lower six. We also cover designers, so you need to know a little bit about designers, design movements, processes, manufacturing as well, and that takes up the other paper. But the big part that everybody really wants to do is the controlled assessment, the piece of coursework. But in the lower six, we try and cover the theory through doing a series of projects. And we will try and do 5 different modules, and each one will take about 7 weeks, and they will cover all the basics of the theory that you need. And at the same time, they will take you back into the workshops and cover new materials as well. There's also maths and science. Don't worry about it though. When we saw the new syllabus and we saw that maths was in it, all the DT teachers started to panic as well. But the maths and science, I'm assured by the maths department, covers very basic things like volumes, calculating areas, percentages, bar charts, that sort of thing. It's all things that you've done at GCSE, but it does come in and it's applied knowledge. So it's not just doing the theory, you actually apply it to your projects. So if we can just go on a little bit. Your non-exam assessment, as it's called, coursework we refer it to, 50% of the total marks, takes the whole of the upper six, and we start it on January the 1st in your lower six as well. You can choose anything. It's entirely up to you. At GCSE, you're given context. At A-level, you're allowed to work in any material and do any project that you think. 45 pages of A3, and you've got virtually unlimited time. You can also do work at home as well under sort of conditions as well, but that's possible. These are some of the projects that we've done in the lower six. We do work in concrete, we do work in electronics, we do work in wood, we do work in metal, we do laminated wood, and we take you through lots of different processes. But each project lasts about 6 weeks, 7 weeks. You do a folder to go with it, and you do some projects which you design and make, and then there's a theory element to go with it. There's some graphics that we've done. This is a project that we also do, a little thermometer, and we base it on vacuum forming materials, working on plastics, so that's the content for that one in the syllabus. We also like to get in some trips if we can. We're about to go off, hopefully. We should have gone to Berlin next February. We go every couple of years to Berlin. We do also fit in a lot of day trips, go to car companies, go to Morgan, we go to a coffee company in Birmingham where they make coffee machines. Go and visit a windmill. You need to know about some of the old technologies, about gear ratios, about why windmills are there, what do we use them for, how were they superseded. We have done trips in the past to Aston Martin, but we do try and get out and look around. Caravan company, why are caravans made as they are? What's the materials inside them? All the design problems of trying to get something into a compact space. In front of us here, I just put out a range of objects. What I really want from people, I want people to be curious. I want you to come down here and think, why is that made from that material? Why is it that shape? Why has somebody designed it as that? All these have been designed by engineers, product designers around the world, all trying to solve a problem. A lot of them got progressions. If you've come through Bablake, you know that in year 9, we look at lemon squeezers. Why does this one cost £50? Why does this one cost £1.50 from Wilco's? What's the difference in the two? Which is the better? I want you to have opinions about things, but I also want you to base it on facts. So we can look at these, test them, work out where the lemon comes. Do you need to catch it underneath? Why is that £50? What's it made from? Any clues there? This one, several different materials, or is it? We can get it apart. 2 different materials. How would you make this material? It's obviously a plastic, but what process do you need to manufacture that? Other lemon squeezers, put the lemon in, does the same thing. If you go down to McDonald's, all these have been collected from takeaway places. All these paper cups, You should have seen on the news recently that the trouble with waxed paper and paper cups, how is it recycled? You need to look at this, and you need to look at the news and be up to date. There'll be questions in the exam about designers. This was made by Philippe Starck. Can you name any other designers? Do you know any others? Can you think of any? Look around you. So do you know your difference from modernism to Art Deco? What's the difference in them? What was Bauhaus? Who was Bauhaus? When was it around? Can you make a product influenced by Bauhaus? So you need to know different design movements, and that's why I want you to be curious. I want you to look at things. All these different toasters. Late 40s, simple toaster. Here's a more modern one. Does the same thing. All they do is make bread brown. Does the same thing. Inside it, it's got the same components, even now, 50, 60, 70 years later. Different phones, all the way up to your mobile phone. How did this come about? Why is this so small? You might argue my phone is not that small, yours is smaller, but what caused it? What was the miniaturization of products that go inside this? What's it all about in terms of electronics? Phone here from the 1950s, still being made in India. Look at the cable on it. Look at the cable on this one. You've got the coil cable, developed in the 1960s. And that's how design evolves. That's how it goes through. And I want you to look at these things and try and put it into context. That's what we're going to spend 2 years doing. Other things, when we go to Berlin, we go to various museums, design movements, look at different things. Controlled assessment, we just talked about, 45 pages of A3. If we go over there, we're going to talk about Arkwright. The Arkwright Foundation, the school is an Arkwright centre. This is for people that are interested in doing engineering. You're going to be a future leader possibly. You've got an interest in maths as well. This will give you a scholarship, and it will give you a link to a company. The company will give you some money. They will give you access to engineers, and they will encourage you into the field of engineering. We've had Arkwright scholars. Eddie Crossley, currently in the sixth form, is an Arkwright scholar. He gets money to spend on design technology products, not on anything. But it's a really good scheme. And if you're interested in that, all the details are in this presentation as well. If you are interested and you're in the GCSE year, then come and see me and we can discuss it further. So really, that's what it's all about. It builds on what you're doing now for GCSE. It takes you a little bit further. It covers the same topic in wood, metal and plastics, but it now puts it more into context in terms of products. So if you're interested, you're curious about things, you want to be an engineer, you want to be a product designer, you want to make these sort of products, you want to influence people's lives, sign up, come along, do A-level. Thank you.